We'll have to do 7, 10 and 7, 9. You do not have to do 7, 7 or 7, 8. But then 7, 6, 7, 5. Yep. So you need to do, I'll type it in the chat. It should be 7, 1 through 7, 6, and then 7, 9, and 7, 10. We have not gone over 7, 10 yet. You've been doing your 2 sections a day? Nice. There you go. So you should be pretty close. Awesome. All right, sorry. Okay, so does anybody have any questions they want to go over? Nope. Olivia, Jack? Okay. Having fun with those discount problems? Uh-huh. Okay. I have my wrong book, so give me like 30 seconds to grab my book and I will do a few out of that section. I'll be right back. Okay, I'm back. So 7, 9, 17 and up. Okay, so let's maybe do I feel like we did 19, but I don't know if we did or not. Maybe 23. Would that be a good one to do? I mean, I could do any of them, so it doesn't matter. Okay, so 23 is 2 to the negative third times 4 squared to the negative 1 divided by 2 to the negative 1. Okay, so there are, when you get to the end here, these few problems, there's multiple ways to do these problems. Okay, can you guys see that okay? My screen's not catching up. I just want to make sure. Okay, looks like you can see it okay. Okay, it was weird. My screen wasn't showing it. So, okay, so there's more than one way to do these problems. The 2 main ways that I see based off of this are, one is, I'm going to draw it in red. One is that we can distribute our variable to get rid of our parentheses. So that would be one choice. The other choice that we could do, I'm going to write in green, is that you'll notice that this is a -1, so we could flip this, and this is a -1, so we can flip it. Okay, so I'll do actually both ways, and I'll try to make it not so messy. So you can see what that looks like. So I'll start with the red method, which is we're going to distribute this -1. Okay, so the new problem, if I distribute this -1 exponent, would be basically 2 to the -3 times -1, because when you have an exponent to an exponent, you multiply them and get together, times 4 to the 2 times, there we go, -1 over 2 to the -1. So this becomes 2 to the -3 times -1 is 2 to the 3rd. And then 4 to the -2 over 2 to the -1. Okay, is that all right so far? I'm distributing that, right? Okay, so now I have some work to do. Now I am going to go ahead, and again, there's even more ways than this. Now I am going to go ahead and say, oh, since this is 4 to the -2, I'm going to rewrite this as, so let me, right next to here, 2 to the 3rd, that stays the same. So 2 to the 3rd, that stays the same. 4 to the -2 is going to become 4 to the +2 in the denominator. Okay, and 2 to the -1 is going to become 2 to the +1. So that way I've gotten rid of all of my negative exponents, right? Now I can simplify it a little bit. So 2 to the 3rd times 2 to the 1st is 2 to the 4th, and 4 squared. So if I actually use my calculator, 2 to the 4th is 16, and 4 squared is 16. So I did this by using my calculator, and I get equals 1. So another method, just so you know, the other method I was talking about is, since this is a negative and a negative, I can just go ahead and flip. So that would be my other choice. So I'm going to flip everything that's in here to the bottom. So it's going to be 2 to the -3rd times 4 squared. And now instead of to the -1, it's going to be to the +1, which just means nothing. And then 2 to the -1 in the denominator is going to flip to the top and become 2 to the +1. So anything to the 1 is just itself, right? So I'm left with 2 times 2 to the -3rd times 4 squared. And now I have a -3 down here, so I'm going to flip that to the numerator. So it's going to be 2 times 2 to the 3rd times 4 squared, which is the same as this. We ended up in the same spot. So, and there's probably 3 or 4 other ways you could do this too, depending on which way you simplify first or second. So the biggest things are remembering, if you have the negative, to flip, that you can distribute the numbers. Yeah, those are the two, definitely the biggest things. All right, would you like to see another example, or? Okay, Try it, and if you don't, let me know. Not a big deal. Okay, so while we're here, I think it's a good time to talk about Desmos. So if you remember on Monday when we were doing, like, for example, 4 or 2 to the 4th power, and some of you said that you had calculators that could do this, and some of you didn't. I know Sophia has like a graphing calculator. And this, we're going to use this more, and then especially when you get to Algebra 2, this is a huge helpful tool. So there is a website and app called Desmos. Okay, so here is the website. It's desmos.com, Desmos. And like I said, there is an app for iPhones. There is also an app for Android. So you can use this on multiple platforms. So this is a graphing calculator, but it can also be used as a scientific calculator. So I'm going to hit this start graphing because actually in chapter 8, we're going to start graphing. So this is a perfect introduction to this. Okay. So when we wanted to find out what 4 or 2 to the 4th power is, Desmos can do this. Now you'll see over here, Desmos is a graphing tool. So it actually is able to graph different expressions. So in chapter 8, we're going to actually be talking about graphing equations, and Desmos is going to be an awesome tool for that. So I can show you what that looks like. But just even like for a scientific calculator, you can see down here behind this, you can type things in like a calculator. So you could do, you know, if you don't remember what 4 squared is, you can do 4 squared. Tells you what 4 squared is. We were trying to figure out what 2 to the 4th power was, right? So one way you could do that is you could write 2, and then this is to any 2 to the 4th power. It'll tell you that's 16. You can also type it in like 2, and then I'm using, oh, it didn't even show. Above my number 6 on my keyboard, I have like a caret button. So this is above the 6 on my keyboard. So if I go in and I put 2 caret to the 4th power, then Desmos is able to tell me what that is. Yeah, so for example, if I'm trying to figure out what, I'm trying to see, I think they kept all the numbers pretty small, but I'm trying to figure out what 7 to the 3rd power is. I can do 7 to the 3rd power. It'll tell me what that is. Okay, so I would highly recommend this. This Desmos takes the place of a TI calculator. It does all the functions that a TI calculator does. There are some choices about whether or not you want to get one with your family. Some people have them with older siblings to use. The one downside to Desmos, so Desmos does all the functions. Do you guys know what I'm talking about? The TI calculators, TI 83, 84. Okay, so I'll show you what that is. You have the app? Awesome. TI 83. Here you go. So perhaps you've seen people carrying these around. This is what I used a long time ago, and that technology hasn't changed much. I hope that doesn't cost that much money. That's crazy. They are fairly expensive though. They're around 90 bucks for a graphing calculator. Oh, shoot. There we go. Thank you. So yes, this is what a TI, Texas, it stands for Texas Instruments, TI calculator looks like. So It's got all this functionality, and you're actually able to graph different functions on the screen. So that's what makes it expensive versus a, just standard scientific calculator. But Desmos actually lets you graph all kinds of equations. So, for example, the next chapter that we're talking about is called linear equations, and linear equations means lines. So we're actually going to be able to say, oh, the equation of a line, and this is a preview, so don't worry. The equation of a line is y equals 3x plus 5. Okay, and then you'll see you type in your equation, and then this actually will graph all the values that are true for y equals 3x plus 5. I realize this is kind of sneak peek kind of stuff. But, just by typing it in the calculator, you can get a graph. And then can get really fancy and graph crazy things like this. This is a parabola. So it's got, this crazy looking thing. And then if I really, really want to get crazy, I could, I'll show you some of the ones that the Algebra II kids are doing. You guys can be doing in no time. This crazy looking graph in purple. So what this represents, just so you know, and we're going to talk about this in a week or two anyway, so it's not like you're just learning things. I'm going to take this crazy one off. So if you see y equals 3x plus 5, if I said that x equals 0, right? If I say x equals 0, that means 3 times 0 plus 5. That means y 5. So if you look on your graph over here, this is your x-axis and this is your y-axis. So if x equals 0, y equals 5. So you can see that that's graphed right on there for you. All right. Likewise, if I say, well, what if x equals, I'll zoom out a little bit. I just lost my point there. Now it's here. So what happens if x equals 1? If x equals 1, 3 times 1 is 3, plus 5 is 8. So y equals 8. So if I go to my graph, x equals 1, y equals 8 as a point on my graph. So instead of, instead of having to plot multiple points, Desmos, you can just put it right in there and graph and evaluate. And we'll be doing a little bit of both. So that's Desmos. It is a graphing tool, but not only a graphing tool, it's a scientific calculator. So we have the standard functions here, squared to any value. You got pi, you've got absolute value. If you go under functions, these are all geometry terms. You can see you can do the mean, mode, median, all that stuff. Yeah, so it's got all kinds of functionality in here that you probably don't need quite yet, but it's able to do that. Sorry, I didn't mean to. So it might not be a bad calculator to just start using, and you can try it, however you think you would use it on the computer, on an app, whatever it might be a good thing to play around with. So you'll be seeing a lot more of Desmos. And one thing I don't even know, if I do 7, let's see, 1 divided by 7 to the negative 1 power. Oh, there you go. All right, so have fun playing with that, right? It's so much fun. I know. You'll actually find it to be very, very, very useful eventually. Okay, so let's get to our last section. And our last section is scientific notation. And I think some of you guys have seen this, but if you haven't, I don't think it's too difficult. So, what is scientific notation? Well, scientific notation is an easier way for scientists and other mathematicians to write really, really, really big numbers and really, really small numbers using powers of 10. Okay, so I wish I had my notes somewhere. Let me see here. I'm just trying to find a real example here. Well, let's talk about what scientific notation is first. Okay, so you see an example that's written up on here. I wish I could darken this up. So this is hundreds, thousands, millions, billions, trillions. This is 64 trillion, 830 billion is the number. 64 trillion, 830 billion is our answer. Our number here. Instead of writing out this huge number with lots of zeros, one thing that scientists do, now financial people would just write 64 trillion, right? But scientists would say that we're going to write this in scientific notation. So what this is it's all based off of tens, right? So a long, long time ago when you were learning math, I'm sure that you learned, you've got your tens and your hundreds and your thousands and so on, and 10,000s. So we're kind of using that to simplify numbers. Then that helps us to be able to compare numbers. Okay, so instead of 64 trillion 830 billion, what I'm going to do is I'm going to say, I'm going to look at my number, and right after the first whole number, I'm going to put a decimal point. Okay, so right after between 6 and 4, I'm going to put a decimal point right here. And then I'm going to count over how many place values did I have to get to that decimal point. And you can see on here I drew 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So instead of writing this huge number, scientists could say this is 6, and then the decimal always goes right after the first number, 6.483 times 10, times 10 to the 13th power. Now, the 10 comes from our base 10, just like I was talking about, right? This is our ones place. This is our tens, our hundreds. Everything is base 10, right? The 13 comes from how many place values I had to move to get my decimal point. Okay, so this we can, instead of saying, what do we say, 64 trillion 830 billion, we could say this is 6.483 times 10 to the 13th power. It's exciting, right? Now, conversely, we can also do this for really, really small numbers. I remember we went to the museum center and they were talking about like micro science, where they're like, dealing with these tiny, tiny nanoparticles and all this stuff. So I can't even tell you what this is. I should be able to tell you. Tenths, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions. I think this is 89 billionth. I think this is how you would read this number. 89 billionth. Okay, but you can see it's a really, really small number, right? We have a bunch of zeros and then we have 89. I think it's 89 billionth. 8,900 billionth. I don't know. I could be off. Okay, so instead of writing this huge, looking number that represents a really small number, we're going to do the same thing. So the biggest trick with scientific notation is that you're going to put the decimal after the first number. So in this case, we have 89. So you're going to put the decimal after the 8. And then we're going to count over how many places that took to get there. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I did the work for us on here, right? So in order to get this decimal after the 8, we have to move to the right. We have to make a really small number, 10 decimal places. So we can rewrite this as 8.9 times 10 to the negative 10th power. And the negative represents really small, right? The small version of that power. Now, what if this number was, well, have you guys seen this before? Does it seem hard, easy? Want to see some more examples before you decide? Yep. Okay. So we have 0.00075. So the biggest trick, well, there's two things. The most important thing is deciding where your decimal is going to change to. So you don't want your decimal to go after, I'm going to write this bigger, 0.00. You don't want your decimal to go here. You don't want it to go after the 75. When scientific notation, you only want one number before the decimal point. So in order to make one number before the decimal point, our new decimal is going to go right in here. Okay? So you only ever want one number before the decimal point. So then we're going to say our new number is going to be 7.5. Okay? I know it's going to be negative because we're talking about a small number. I have to move my decimal 1, 2, 3, 4 spots. So this is going to be 7.5 times 10 to the negative 4th power. Okay. Yeah. Now, if you go, let's see, let's try something. I could be totally wrong. Let's go to Desmos. What if I type in 7.5 times 10 to the negative 4th power? Oops, that's not. First of all, you should type it in correctly. That would help. All right, come on. Oh, there you go. So it evaluates it for you. So I'm going to tell you one other thing. I don't know if it's going to confuse you or not. Okay. But just another way to think about this. So 7.5 times 10 to the negative 4th power is the same as 7.5 times 10 to the positive 4th power, right? Because it's a negative and you can flip it. That means this is 7.5 over, I always forget how many zeros it is. I think it's 4 zeros, isn't it? You know how you have that one math thing that I'm always like, I think that's right. Yeah, okay. It is 10,000. It's 4 zeros. All right, 7.5 divided by 10,000, right? And if you do that on your calculator, you're going to get 0.0075. Yeah, so in order just to do scientific notation, what you're trying to figure out is you're trying to figure out where to move the decimal point to and how many places away that is. So let's do some more examples. Okay. We'll do this one on the page. So we have 20,940,000 something. Okay. So let me write this out bigger. Okay. So this is a big number, right? And we're going to write this as a power of 10. The biggest thing is figuring out where your decimal goes. So we have, a lot of people might be tempted to put the decimal like right here between the 20 and the 9.4. But whenever you're using scientific notation, you're only going to take one place value. You're only going to take one number. It's going to be the first number that starts your number. So you're only going to let one number be before the decimal once you have scientific notation. Okay, so my number is going to be 2 point, it doesn't like when I draw points, 2 point, and then all the other numbers behind it just come along, 0, 9, 4. And we're not worrying about any of these other zeros after that. So that's the first part. I know it's going to be times 10. Now I have to figure out which power it's to. So in order to get my decimal up here by 2, I had to move forward 1, 2, 3, 4, 5, 6, 7 decimal places. So this is going to be 2.094 times 10 to the 7th power. Okay. So let me do some more. Okay. So for example, trying to find some real examples here. Because I think it's actually interesting. I don't have a good example for you, but let's just go ahead and do a few more of these, okay? Just make sure you guys got it. Whoa, that's not what I meant to do. Okay, so what if I have the number 3,030,000? Okay. And I want to write this in scientific notation. So what I have to figure out is, first, where am I going to move my decimal place? Because my decimal place is right now, it's right here, right? And I need to change this to a number that has only one number before the decimal. So in order to have just one number before the decimal, I'm going to move my decimal place to right here. So my new number is going to become 3.03. Then after that, I don't have to worry because it's all zeros after that, right? I know it's going to be 10. And then I have to look at how many places did I move? 1, 2, 3, 4, 5, 6 times 10. No, not that, not times. 10 to the 6th power. Yep. Because we're always working on a base 10. Yes, always times 10. Every scientific notation is times 10. Always, always. Yes. So why don't you guys try? Yes, sorry. Always base 10. So I'm going to write number 17 on here, and I'm going to try to write it with the right number of zeros, and I want you guys to try it. Okay. This is 17 from your book. Zero. All right, so I'm going to give you guys a second to try to write that in scientific notation. And I'm going to grab a drink real fast, so I'll be right back. Hey, the lunches are ready to play with if the kids want to get ready. The lunches are ready to play with. All right. I don't know. I might text you and let you know. I'll text you and let you know. Because I'm still finishing up. Okay, I'm back. Sorry. All right, I see answer from Olivia. Jake and Jack, do you think you have something? Yep, you're right, Olivia. Your computer is crazy. All right, so most important thing is figure out, excuse me, my voice is giving up. Where does the decimal point go? So the decimal point goes wherever you can make, it's only going to have one decimal point. You basically only want to the ones place value. Okay, so what I mean by that is you want to put your decimal point right in here because that means your number is going to be 2.4. You would never see scientific notation written like 24 times 10 to the something. That would not work. It always has to have just one place value, one in the ones column. Sorry, my voice is being crazy. Okay, so then we need to see how many place values over is that. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's always going to, what's that? Yep, start from wherever the decimal place is starting from. So basically, it's like your decimal place is bouncing bouncing from where it started to its new spot. All right? So it's going over 9 places, and since we're talking about a small number, it's going to be to the negative 9th power. Okay, so it's negative when it's a really small number because really that's like dividing 2.4 times 10 to the 9th. So that means you're going to get a really, really small number. When it's a big number, you're going to have the positive exponent because you're going to make your number even bigger. That's the answer. That's it. Okay. So the other two examples, we're actually going to kind of do the opposite. And we're going to, sorry, my voice is crazy. Give me just a second. Okay, that's better. All right, so the other way that we're going to do is we're going to take something in scientific notation and change it to regular numbers. So we're going to like go both ways, basically. So number 3 says that the area of the United States is 3.6 times 10 to the 6th meters squared. Okay, so now we're going to kind of do the opposite of scientific notation. We're going to make this into regular notation, right? So what does this mean? Well, I have 3.6 times 10 to the 6th power. So one option is you can just multiply it. The other option is that we know that when you have something to the 6th power, that means it's a really big number, right? Because it's positive. So the positive means a big number. Big number, right? So we can say that we're going to make this number bigger. We're going to add some zeros on because we're allowed to do that. So it's times 10 to the 6. The decimal is going to move 6 places. 1, 2, 3, 4, 5, 6. Okay. So my new number is going to be 3,600,000. That's another way to write 3.6 times 10 to the 6th power. Now this we can actually check on our Desmos, right? We can check on our calculator. So if we switch back to Desmos and we do 3.6 times 10 to the 6th power, we get 3,600,000. So can you see how they relate to each other? One goes one way, one goes the other. Kind of. Yeah, I think it is a little easier to go that way. Okay, and what about a really small number? 1 times 10 to the negative 9th. This is the time for a supercomputer to do a calculation. Now, given how old this textbook is, this is probably like the time for your, phone to look up something. I don't even know. It's probably way faster. So what's weird about this is we don't have a decimal place, but we can just assume it's 1.0, right? Times 10 to the negative 9th. Well, when it's a negative number, it means it's going to get really, really, really small. So we're going to have a really small number. So what I actually do is I draw a bunch of zeros, and then I say, okay, my number at the end is 1.0. Since I have negative 9th, I'm going to move my decimal 9 spots. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So my new decimal is going to be here. It's going to have 8 zeros and a 1. So another way to write 1 times 10 to the negative 9th is 0. And then I got to do 8 zeros. 3, 4, 5, 6, 7, 8, 1. That's a 1 there at the end. Okay. So I want you guys to try these. If you try them and you have questions, bring them to class on Monday and we'll go over them, okay? There is one last example that I wanted to show you, and I'm honestly just going to show you this one. It's actually example 4 in your book, but I just think it's interesting. This is kind of the, sometimes you're like, why are they making us do this? Now, this is not something you'll use every day, but okay. So it says the distance from the sun to Mercury, the sun to Mercury. So we're talking about planets here. Nope, I spelled that wrong. MER. The distance from the sun to Mercury is 6 times 10 to the 8th kilometers. The distance from the sun to Pluto, which may or may not be a planet. Did you hear it might be a planet again? Is 5.9 times 10 to the 9th kilometer. So if you're looking in a book, right, and you're, excuse me, and you're seeing these distances, sometimes it's really hard to think like, what does that actually mean, right? Like, I know that's a huge number, that they're really far away from each other, but what does that actually mean? Well, when you write numbers in scientific notation, what you can do is easily compare numbers because both of these numbers are basically 6, right? 6 or 5.9, they're basically the same. They're around 6, right? But if you look at the powers, Mercury is 10 to the 8th and Pluto is 10 to the 9th. That means that Mercury is 10, or Pluto is 10 times further away from the sun than Mercury is. So it can give you, because we have 10 to the 8th to 10 to the 9th, can give you a really fast idea of, magnitude of differences. So we would say that Pluto is 10 times as far away from the sun as Mercury is. So that's why scientists write it like this. Because if it was written like, so if I wrote this first distance, it would be 1, 2, 3. And I wrote Pluto, it would be commas. So if I had them written out like this, it's a little bit harder to tell. Like, I mean, you can kind of see because the numbers are close, but it's harder to tell what is the difference in the distance of those two. So that's why scientists use scientific notation, because it helps with the scale of size. What's that? Yeah. Cool. Well, you guys try those out. Like I said, if you get stuck, bring your questions on Monday and we'll go over them. I probably will. What's that? I don't think there's not that many. Oh, your notes. 1 through 7 odd and 15 through 25, and you only have to do part A. So that's not very much. That's like less than 10 problems. guys could finish them right now, right? All right, good deal. Thanks, guys, for coming. I will see you on Monday where we'll start chapter 8. Bye. Thanks.